Here's the next question, number 37. The RMS value of the resultant current in a wire which carries a DC current of 10 amps and a sinusoidal alternating current of peak value 20 amps is. Now, first let's write down the expressions given. We have the value of the DC current IDC given as 10 amps. Sinusoidal alternating current of peak value 20 amps. So IAC is now written as 20 sin t because we have to consider the alternating signal given, the sinusoidal alternating current. So 20 sin t is the expression. Now let's write down the total current. I of t is given as IDC plus IAC. That is the resultant current. So we add up both of these parts to get the expression. So our expression would be 10 plus 20 sin t. Now we have been asked to find out the RMS value. So to find out the RMS value, we will use the following formula. So the formula for the RMS value of current would be IRMS is equal to 1 by 2 pi, that is our total time period of t, 1 by 2 pi because it is sinusoidal, right? So that's 1 by 2 pi, 0 to 2 pi, I of t square dt, and the entire part is under root 1 by 2. So this is our formula for the RMS of a waveform. So IRMS would be 1 by 2 pi, 0 to 2 pi, IT square dt to the power of 1 by 2. Now we have our expression for I of t to be 10 plus 20 sin t. Now we have to square this and substitute. So let's do that in the next step. Now let's substitute the expression for I of t. What do we have here? We have IRMS is equal to 1 by 2 pi integral of 0 to 2 pi. Now I of t is 10 plus 20 sin t whole square dt, the whole under root. Now let's expand this expression 10 plus 20 sin t whole square, okay? So that's our next step. That's 1 by 2 pi integral 0 to 2 pi. Let's see now, this is 100 plus 400 sin square t plus 400, and this entire part is under square root. Right. Okay, now let's solve this further. What we are going to do next is to convert the sin square t in terms of cos t. That's our next. Okay, so we now have 1 by 2 pi integral 0 to 2 pi. Okay, so here sin square t can be written as 1 minus cos 2t by 2. So we write it as 100 plus 400 into 1 minus cos 2t by 2 plus 400 sin t. The whole of this expression is under root. Okay, so now 400 into 1 minus cos 2t by 2 is 200 times 1 minus cos 2t. That's our next step. And we now have IRMS is equal to 1 by 2 pi into integral of 0 to 2 pi 100 plus 200 times 1 minus cos t cos 2t plus 400 sin t dt, and the entire thing is under root 1 by 2. Alright, Now the next step. Here, when we open up the parenthesis, we have now 200 times 1 200 minus 200 cos 2t. Now because we are looking for the RMS value, we will have to take the peak value of the entire expression. So we are now going to consider this as 1 divided by 2 pi, integral of 0 to 2 pi, 100 plus 200 is 300 dt. 1 by 2. Now the reason we have done this is because cos and sine are trigonometric functions, and that would lead to the reduction of the value by a small percentage. Because we are looking for the peak value, the RMS value requires the constants alone. So we consider only the constants, 100 plus 200 here, which is 300. So 1 by 2 pi, integral of 0 to 2 pi, 300 dt to the power of 1 by 2. Now let's further solve this. 1 by 2 pi, 300 t at 0 to 2 pi, and the whole thing under root. So that's 300 divided by 2 pi into 2 pi, isn't it? So that's 300 times 2 pi divided by 2 pi, 1 by 2. So here 2 pi cancels out. We are left with only root 300. So root 300 gives us a value of 17.3 amps. So 17.3 amps is the final answer, and that matches with option B. So here for this question, the final answer is B, 17.3 amps.